Hey everyone, in this video, I'm going to be going over the concepts of trees in computer science. So to begin, I'm going to go over some terminology. So a node is a data source in a tree. Basically, you can think of a node as an object that represents like a piece of data in a tree. And the root is the first node in a tree. And each tree has one node only. If a tree has no root, so each tree has one root only. If a tree has no root, then there's no tree. An edge is a line connecting two nodes. And a parent node is any node that has a child node. And a child node is any node that has a parent. And a leaf node is a node without any children. And there's different types of trees, but the trees that I'll be mainly focusing on in this video are binary trees. Binary trees are trees where each node can have at most two children. So some nodes can have no children, which is fine. Some nodes have one children, which is fine. And some nodes have two children, which is fine. But no nodes can have more than two children. So if you look at this example, this node is a root, and all these circles are nodes. And this node here, like this one, that's root because it's the first node in the tree. And you can see that this node has two children, 3 and 2. And you can see that 3 has two children as well, 4 and 5. Whereas 2 has one children, 7. And you can see that 4, 5, and 7 have no children. So these are the leaf nodes. And these red lines are the edges because they connect the two nodes together. So now I'll be going over some different types of traversals. So the ones that I'll be going over are in order, pre-order, post-order, breadth first search or BFS, and depth first search or DFS. So in order traversal. In order traversal is left, like you traverse it left, root, right. And so using the tree from slide 3, so this one, let me just quickly draw this on this board here. So we have, so this is our tree. Let me see. It's 4, 5. Wait, so in order traversal, like I mentioned, it's left, root, right. So let me just write this quickly. Let me just write this down. So in order, you traverse it left, root, right. And so you start at the leftmost node here, right? So in this case, the leftmost node is 4. And then we have the root is like 3, and then we have 5. And then we have 1. We have this one here. And then we go to the right subtree. Now there is no node here, right? So in this case, we don't have a left. Left is null. So we have 2, and we have 7. And you can see this is our 4, 3, 5, 1, 2, 7. 4, 3, 5, 1, 2, 7. This is our in-order traversal. Our pre-order traversal, we traverse it as root left to right. So let me write that here. So we traverse a root left, right. So in this case, we start out at the root of the entire tree, which is 1. And then we go to the left subtree. So here, what's the root? The root is 3. And then we have 4. And then we have 5. So 4 because it's left, 5 because it's right. And we're done with the left subtree. So now we go to the right subtree. Again, the root is 2. So we have 2. There's no left. Left is null. And then right is 7. So our pre-order is 1, 3, 4, 5, 2, 7. And then we have post-order. Post-order, you traverse it left, right, root. And so let me write that down. So here. So you have left, right, root. So again, we go to we focus on left, right? So left, like we look at the leftmost node. In this case, is 4, and then its like right counterpart is 5, and then the root is 3, and then that's like that's left. So now we go to right. So in the right subtree, there's no left. There's the right, which is 7. The root is 2, and then finally, let me move this a bit over here, and then finally we have the root of the entire tree, which is 1. So this is 4, 5, 3, 7, 2, 1. So how I like to do this, so I guess like if you see like left, for example, like for in order post order, you start out left. That means like the leftmost node, and then it's like from there you find like the root of like that subtree, and then like the right of that subtree, and then you just keep going up or going like just like going up or going right. So for in order, pre-order, and post-order, there's only like one like one solution. Well, not one solution, but like one like result. For the other two that would then be covering BFS and DFS, there's a couple of different like you can get a couple of different results. So BFS stands for breadth first search, and this means that you traverse the tree level by level. You don't have to do necessarily left to right. That's just my my preference. So for example, here, right, BFS. Oops. For BFS, so you traverse the level by level. So you start out at the root. So that's fixed. So this is, you can think of it as this is like the first level. This is the first level, and this is the second level, and this is the third level. So for BFS, my preference is to traverse from left to right. So I'll do 3, 2, and then I'll do 4, 5, 7. But for BFS, the main point is like you're traversing level by level. There's usually no strict requirement that you need to go left to right. You can also go like right to left, like in some other order. I just prefer left to right. And finally, the last traversal that we're going to look at is depth first search with DFS. And what this means that is you traverse a tree down a path as deep as possible. And once you hit the leaf node, you back up and you try a different path. So let me erase these 2 lines. Let me change color. Let me use red. So again, we start out with at the root node here. And so again, like I'm just gonna go like left to right. So what I'm gonna do is I'm gonna go down this path because it's left. I'm gonna go down this path. So I guess DFS. So we traverse down a path and then backtrack. So here I'm going to do 1, 3, 4. At 4, we hit a leaf node, so we backtrack, so we go up, and then from here I'm gonna go visit 5. But 5 is also a leaf node, so we go back to 3. So again, this is backtracking. We visited all the child nodes of 3, so we backtrack. So we visit 1. So we go back to 1, and then we go down this path. So we go to 2. And from 2, we go to 7. And from 7, 7 is a leaf node. So we can't go any, like, there's nowhere else to go. We go back to 2. We visited all the nodes of 2, so we go back to 1. We visited all the nodes of 1, so we're done. So in this case, it's 1, 3, 4, 5 to 7. 1, 3, 4, 5 to 7. And again, like you can choose any different path. Like you could have went like from 1 to 2 to 7, like 1, 3, 5, 4. that doesn't really like the order doesn't really matter too much. I just prefer going from left to right. So now let me show you the code I have. So here what I have is I have this node class, and so you can see like each node has a data, a left and a right. Left and right would just mean like left child and right like right child. And so here in order, again, in order you traverse left, root, right. So this is like a recursive algorithm for in order traversal. Again, there's like different types of like variations, right? Like you can do it recursively, you can do it iteratively. There's like 1,000 different ways of doing this. I'm just showing like what I have here. So again, I recursively go down the left path, and then print out like the data, and I recursively go down the right path. And so here, right, this is basically what I'm doing here. Is like I'm remaking the tree. I'm remaking this tree. So you see I have like these nodes, and then so root to left is child 1, which is 3. Root to right is child 2, which is 2. You see this is root. This is like child 1, child 2. And then we have child 3, 3, 4, 5, and then child 1 to left is child 3. Child 1 to right is child 4. So again, here, right, the left child and the right child, and then finally child 2 to right is child 5. And so this this inward loop just prints out the inward traversal of this tree. So if I do that, let me move this over here. 3. You can see it 4, 3, 5, 1, 2, 7. 4, 3, 5, 1, 2, 7. It's the same thing as I have here. And again, we have the pre-order, like the code for pre-order traversal. And again, so again, this like a different ways you can do this like algorithm. This is the way I chose, like recursively. And so again, right here, like this part's the same thing. This part's gonna be the same thing for all 5 of these files. And then here I'm gonna do the pre-order. So Python 3 pre-order. You can see it's like 1, 3, 4, 5, 2, 7. Pre-order is 1, 3, 4, 5, 2, 7. Going to post order, I mean it's the same thing. Let me just do Python 3 post order. It's 4, 5, 3, 7, 2, 1. 4, 5, 3, 7, 2, 1. And then here, so for BFS, right? For BFS, you can do it recursively, but for BFS and DFS, I usually prefer to do it iteratively. So for BFS, let me go back to the whiteboard. And let me scroll down here. So remember, let me change the color. Recall that BFS means that you're traversing level by level, right? So BFS, B. You're traversing level by level. So suppose we have like this tree. Sorry, this should be a different, this should be for example. The iterative approach for BFS is to basically use a queue. So what I'm gonna do is I'm gonna use a queue. And for those of you who don't know, a queue is a first in, first out data structure. So basically like the first object or like element that goes in a queue is the first one that gets removed. And in this queue, I'm gonna use like represent a queue using an array, and I'm gonna initialize the queue to have one element, which is the root node. And again, if this is assuming that that there is a like a root. And what I'm going to do is this. So while queue, and what this means is as long as queue has an object like this, well, so as long as queue has an element inside it, we're gonna be running this inside this while loop. So while there's at least one element inside queue, I'm gonna pop the first element inside this queue. And again, remember this is queue's FIFO, first in, first out. So I'm gonna pop the first element inside this queue. I'm gonna call this a node. And if node dot left exists, we add it to the queue. And again, you can do like queue dot right first. It's really just like a matter of preference. And similarly, if there's a right child of that node, we also add it into the queue. And you should probably print the node. This prints the value of the node. So if I were to do like a what do you call it, like an example using this tree, right? So and for the queue, I just use this since it's the same thing basically. So at the beginning, right? So at the beginning, we initialize this queue to have the root node, and to represent each node, I'm just going to use the value. So it's going to be 1. So while queue, so as long as there's an element in queue, what's going to happen is we're going to I guess I'll do the first iteration. So first iteration, our node is going to be equals to this 1 because we're going to be popping this 1, right? And does this node have a left child? Yes. So node dot left is equal to 2. Does this node have a right child? Yes, it does. It's this 3. So node dot right equals to 3. And then so we append both of them to queue, right? So afterwards, our queue is going to look like this. And then finally, we print out the node value. Our second iteration, the node this time is going to be 2 because again we're popping the first, or not popping, like we're removing the first element from the queue. So does this node have a left child? Yes, it does. It's the 4. Does this node have a right child? It does not. So this would be like none or null, whatever. So we're only gonna append the left child into the queue. So now our queue is 3, 4. And let me zoom out a bit and scroll down a bit. Okay, so that's the second iteration. Our third iteration, let me do it here. This time, our node is going to, the node that we pop is going to be 3. Does this 3 have a left child? No, it does not. So node dot left, I'm gonna use none to follow Python's like coding style. But it does have a right child. So node dot right is 7. And so our queue is now going to be 4, 7. Right? Because we are appending this node dot right to queue. For the fourth iteration, the node that we pop is going to be the 4. So four is a leaf node. So there's no left or right child. Yeah, there's no like left or right child. So the queue will just be 7. And finally, the node that we pop is 7. Again, 7 is a leaf node, so there's no child. And now our queue is empty. And at this point, we break out of the for loop. Sorry, while loop, so while loop. Just because there's no more nodes in the queue is empty, so this condition will fail. But yeah, so here, this is our BFS. Yeah, and this is BFS, and the way I have it is like we traversed the tree level by level from left to right. Again, you can see this is very similar to what I just wrote. And so if I do this, let me just do it clear first. So clear. Python 3 BFS. you can see it's 132.457, and here BFS 132.457. And finally, we have DFS. So DFS, again, this different, you can do it iteratively or recursively. I think most people prefer the recursive method, so the recursive style for this. I myself prefer the iterative way. But just like how with BFS, we use a queue, for DFS, we're gonna use a stack. And for this one, I'll let you guys like play around, like do some tracing, do some examples, see how it works. Let me just do this. Python 3 DFS. And you can see it's like 134.527, 134.527. Yeah. Well, one thing with a stack is like a stack is a LIFO. It's a last in, first out data structure. Whereas a queue is a first in, first out data structure. Yeah, I'll let you guys like play around with examples to see how the stack works. And yeah, all of this, these code I'm showing here, it can be found on my GitHub repo, which I'll be linking in the video description. Thank you all so much for watching, and I hope you learned a lot.